Hello, welcome to lecture 40. This is James, and we've been finishing all of those conceptual lectures by last time, right? So I was kind of rushing, right? Last time especially, but I'm going to cover all of those things. So let's go to the board and let's solve questions, a lot of questions, right? So 1998 AP BC would be your right now the materials that you're gonna look at, and I'm gonna speed up. I'm gonna rush, but I'm not gonna rush as I do when I teach. I'm gonna rush as I'm gonna equal my speed. Well, I'm gonna make myself kind of speedier so that I could actually follow up to the levels of your just mental thinking and kind of show you this is the amount of time you have to use. So number one. All right, so let's see. So number one is just like figuring out. So increasing, right? It's figuring out the intervals of increasing, which means this is like f prime, right? So you have to at least spend times at least a minute in this case, or 45 minutes, just writing it down, right? So f prime in this case, it is equal to 6x squared plus 6x minus 9, right? And in this case, what do we have? 3 to the 2x squared. Oops. Am I right? 6x and 3x squared. What am I doing, right? So writing it down, we have a common factor, right? 3x squared plus 2x minus 3. In this case, 3 to the x minus 1, x plus 3, right? So it has to be bigger than 0, so we could delete 3 because it's just a constant. It doesn't affect the value of this thing. So what do we have? So x has to be bigger than 1, or x has to be smaller than -3, right? That's the only thing that you could think of. And the answer for that is C. So C is the answer, and I spent just a minute in this case because I was writing it down, but you only had to take 30 seconds. So number 2, well, you have to remember, well, this is the thing. So we want to figure out dy over dx, but x is in terms of t, right? 5t plus 2, and y is equal to 3t for a certain local domain, right? So 3t and 3, and we want to figure out about this thing. So how can we write this dx over dy? Well, dy over dx is equal to dy over dt over dx over dt. And using this fact, using this property of a common factor, and we just deleting it, we could write x and y in terms of t, so dx over dt. So what is dx over dt? What is dx over dt is a good question, and dy over dt. Well, just take the differential, right? Dx over dt is equal to 5, right? And dy over dt is equal to 3. Well, dy over dt over dx over dt is equal to, well, 5, right? Is it 5? Dx over dt is 5. 5 over 3, dx over 5 over 3. Well, it's not 5 over 3. Let's see. What am I wrong? Where am I wrong? So dx over 5, dx is 5 over 3. So 3 over 5 it should be your answer, and that's number 8, right? All right, so that was like 30 questions, 30 minutes, 30 seconds, right? So number 3, the slope of the line tangent to the curve y squared plus xy plus 1 cubed is equal to 0 at 2 and -1. So this is a question of what? This is a question of implicit function. Implicit differentiation. Implicit differentiation. Which means we do know about differential calculus by now, but in the differential equation, but I haven't talked about this thing because it was relevant. This implicit differentiation is relevant to the question on AP more relevant, and this will be dealt. This is dealt in my differential calculus. So if you know about this thing, y squared plus xy plus 1 cubed is equal to 0, and take the differential in terms of what? In terms of x. So 2y and y prime, implicit function, this is dy over dx in our case, and 3 to the xy plus 1 squared, and what is this? xy is a product of two functions, right? And product, we need to use a product rule. So xy prime plus y, which is equal to 0. Well, plug 2 is -1 as x and y. Well, plug this thing. What do we have? 2 to the -1 to the y prime, right? Plus 3 to the, what is it? In this case, -2 first, plus 1 squared, and 2y prime minus 1 is equal to 0. Well, this is just an arithmetic. -2y prime is equal to 3 times 2y prime minus 1, which is equal to 0. So -2y prime plus 6y prime minus 3 is equal to 0. So 4y prime is equal to 3y prime, which is dy over dx is equal to 3 over 4. And the answer for that is D. All right, so that was a minute question because of writing it down, right? So number 4. What is number 4? Integral x squared minus 6x plus 8 dx. And as soon as you see this, f of x is equal to 1 over x squared minus 6x plus 8, right? But this is a form of what? Remember what? Remember, this is at least a minute and 30 seconds a question, right? So for this one, what do you have to remember? What do you have to remember? Distinct linear factors. Distinct linear form, right? Linear factors, which means partial fractions. Right, 1 over x minus 4, x minus 2, which could be written as 1 over 2, 1 over x minus 4 minus 1 over x minus 2, right? Right. So, what is it? What do you have to do? You are using this fact, right, and writing 1 over 2, 1 minus x minus 4 minus 1 over x minus 2 dx. And constants could be pulled out, right? And so 1 over 2, and let me just like, you know, use a lot of like thinkings. We already do know integral 1 over x minus 4 is what? X minus 4 is ln x minus 4. ln x minus 4 minus 1 over 2 minus 1 over 2 ln x minus 2 plus constant. And we could change this thing into 1 over 2 ln x minus 4 over x minus 2 plus constant. And do we have this form in the answer? Obviously, yes. We do have an answer as A. Well, here's the funny thing. Number 4 is just using distinct linear factors. It's not that hard, even though you can't look at this answer properly right now because it's at the end of the board. But just remember the fact that we are using a thing that we already learned. All right, so let me erase this thing. Let's go to number 5.